So, remember what a common log is? 10 what? Base 10, right? And it will be written without the base actually noted, right? Ooh. Okay, fine. Okay, so one of the ways to use common logs is with the change, what's called the change of base formula. So again, back in the old days, the calculators we had came out about the time I graduated high school. We used to have tables in our books that gave us every base 10 log as a decimal value. It's like several pages of just tables. And it would say log 51, and it would give you like 0.568 or whatever it was. Okay. You have a calculator now, so it's not as big of a deal. But if we were asked something like that, it's not a common log, and we needed the answer to it, we had to go to those tables after using the change of base formula. Okay. So we would change this to base 10, then go to our tables and calculate our answer. Okay. So the change of base formula changes it to base 10. Or any base you want, really. You can do it with whatever base you want, but base 10 is the easiest. Okay. So this number here goes on the top, and the base here goes to the bottom, and these are both base 10 now. That's another way to deal with logs that have a funky base. I really have a calculator. Log, don't forget to close your parentheses there, and log 4, right? So, there you go. Do you remember how to do it without having to change the base?
No.
Yeah, with math.
Math? And what? Yeah, log base. And then you can do this way. So you can just see that. So again, it's handy once in a while, but since we have the tech, it's really not necessary as much anymore. Let's change base. Have we talked about solving equations with logs and exponentials? Like if I give you 6 to the 3x equals 81.
No.
Have we discussed solving those equations? Okay. This is probably I think we did, but we'll just let it go. So this is an exponential, correct?
Mm-hmm.
Okay, so we have an exponential. What's the inverse? Yeah, we did talk about this. What's the inverse of an exponential?
Yeah, I think we went over.
Yeah, it's a log, right?
Yeah.
So how would I get rid of this so I can isolate the x? Well, it's an exponential. If the inverse is a log, what would I use to get rid of the exponential? Log base 6. for both sides.
You do log base, you would both on a log base,
No,
or not?
it's not a multiplication, it's a function. Right, logarithm is a function, so you're doing a function each side. So these two would actually go, right? 3x, and then what is log 681?
Oh.
So it gets rid of the exponential, right?
Log 681 is 2.452.
Okay. And now what do you do? Yeah, divide by 3, right? .9er. Anybody? I don't know what the answer is.
Just 0.817.
There you go. And you keep in mind, this is a multiplication, right? So what's the inverse? Division. It's that whole inverse operation. When you're solving equations, you're just doing inverse operations. So you get x isolated. Okay. So if you remember all those relationships like this, you just have to use those. Ugly as 5 in history, but we're going to go with it.
Yeah.
How do you solve that problem? Again, think about it. How do you get rid of the log? Because you want to isolate x, right? Yeah, so you raise this as an exponential. That's a big number. So x is. See if that actually gives you an answer. Does it have an e in it?
Yeah.
What is it? Let me give you a little tip on your calculator.
Oh, and then the money benefit. It says 1.125 times
1.15.
Yeah. 1.2.
Messing me up with the math.
I thought you heard that.
Okay, so scientific notation there. These calculators would probably write it like this. Is that what, something like that?
Yeah, PreCalculus.
Yeah, this is scientific notation in the yellow calculator terms. So, same thing right there. I'm sure at some point they'll figure out how to put times 10 to the 15, but not yet. Could you? Okay, so these are algebraic solutions, right? Graphically, using your calculators, can you think of a way to solve this equation? It's a pretty handy skill. It makes things a lot easier, actually. I'm going to put both of them in y equals. So 6 to the 3x. And 81. That's different functions. X. Not really. Let's change our window. So we know that the y value is 81, right? So I'm going to put my window for y values somewhere from 75 to 85. Since we already know the answer, I can put 0 to 2 for my x's, but sometimes you have to kind of mess with that a little bit. So there's 6 to the 3x, and there's 81. How am I going to figure that spot out?
Just in the table.
Is it
Trace.
you could trace it, it won't be as accurate. And so you can trace,
Is there a formula we have to do to find that point?
see how inaccurate that is? Yeah. It's 77, but then it bounces to 86. It never has right there. There's a function on your calculator that will do it for you. Anybody remember what it is?
No.
What menu do we go to a lot? Calculate menu. Intersect. We want one of those graphs intersect, right? So the first curve is 6 to the 3x, hit enter. The second curve is 81, hit enter. And now you can venture a guess with the cursor. And boom. So if you have an equation, you can put them in each function, calculate the intersection. Should be pretty close.
What did you call it?
You got that?
Like 30.
Good? Y'all are way awake today, just like AJ.
Yeah, AJ's just jumping up and down right now.
Welcome back. Why don't you keep your head up so you don't have that issue anymore? Okay. So you can use your calculator to solve these, but make sure you not do this by hand, because that's usually how we attack it. I showed you a chemistry example calculating pH, correct? Yeah, last week. So that's in your book as well. Do you have any, did this clear up any issues you had on the homework?
Yeah.
Okay. I mean, this is probably the most important part of the section, solving these equations. Okay. That's all I got. You can fix up that work now. You would probably want to study for a unit circle quiz, because you'll have one by the end of the week.
This week?
Yep. It's tomorrow or Friday, you'll have a unit circle quiz, and it will have the logs and exponential properties on it. So if you want to sit here and quiz each other on those and study for that, you can, or you can work on your homework. Okay? That would be fine. You already have the homework, do you want me to write it down?
That's how.
Write it down.
You think that much paper is like, they can get through the rest of the school year? If you keep doing it. I did this morning. I've been. I have to do this morning.
That is due tomorrow. I apologize, I thought I said due, I didn't say due Wednesday, I thought, I just got things crossways. But I have an excuse, right?
Yes. No.
No excuses, just don't suck.
Excuse. You would not.